is Jonne Soininen on the very top.
Ah, yes, sorry.
Not at all.
Other people's names are the other way around, so I was looking for your surname at the start.
Open with.
There we go.
And control. Excellent. Looks good.
All right, welcome back, everybody. The last hour or so of content. Hope you're all enjoying the day. We're lucky to have another open source presentation now from Jonne, and I'll hand over. Thank you.
Thank you very much. So, hello, I'm Jonne Soininen from Nokia, and I'm going to talk a little bit about something else than what has been discussed the rest of the day today. What I'm going to talk about is a little bit on a project that, or an organization that's under Linux Foundation and called Linux Foundation Networking, and then a specific project underneath it called ONAP. What I'm going to say is a few words about what we think about open source in general and what we think is important about open source. And the thing is also that how do we define open source in this discussion? So the thing is basically that in the telecommunication world, at least, now open source is becoming actually quite a bit more important. It's not something that necessarily will come to the router layer, but especially on the cloud side, well, we talked about OpenStack already today at one point, and on the management side, open source is something that is becoming actually quite used already. Open source, of course, only means that it's software that happens to have a license that allows you to distribute, use, and look at the code and do with the code whatever you want within the bounds of the license. But when I'm talking here about open source, what I mean is software that is done within a community or as a community together, and looked at as something that basically it's part of where people come together to do something, and that has an open source license, of course, on that. So when we looked at that somebody doing open source or software as a community, or even standards or anything like that, the first thing what you need is a shared problem, something that everybody goes like, yeah, that's something that should be solved. The next thing is what people need there is also to understand that, well, yeah, we want to solve it in the same way. We think we see the same problem, and we have an interest of doing that. So you need alignment of basically saying this is the problem that we have, and most probably we understand that what the solution is together. And then you need the support that basically people going, well, this is actually a problem that I need to solve, and I'm willing to put my people or my resources or my time personally behind that. And those are the most important ingredients for open source to really happen and succeed when you do it as a community. Of course, what you need as well is the right timing. So when you look at that, it's basically something that you're not just starting a new project, for instance, that somebody else has already a project in that space, just with new people, or that also that people are ready to take an open source solution into use, that you are not, for instance, in an industry where people would be adverse to that, and that the people are actually want to see that problem solved in that time. What is often forgotten is what you also need is the right governance model, which means that people who want to be involved in this can actually be involved, and they feel welcomed in the community itself as well. Open source, of course, and this is, as a vendor, you have to always remind people of this, that open source is excellent. You get stuff for free. But you don't actually get stuff for free. It's not for free. It's not a product what you get. What you get is actually just software. You can run it yourself if you decide to support it yourself and you decide to maintain it yourself. That's fine. But even if you do that, you most probably at least have to contribute something back when you find a bug or so on. So open source is something that, well, like Richard Stallman likes to say, it is free as in freedom of speech, not free as in free beer. So in that way, the kind of like, I'm of course now doing here the freedom of speech, and I hope we are doing a little bit later the free beer, which is a different thing. The open source also, that there is a lot of discussion, and some people are saying open source will replace completely standards. We don't think that that will happen. The difference between open source and standards is basically that open source really standardizes one implementation. And it's very useful when one implementation is enough. So if you are looking at something like OpenStack, yeah, that's something that where one implementation makes a lot of sense. If you want to do it in technology that way, well, why don't you do it all in the same way? However, in places like, for instance, TCP/IP, that wouldn't make sense to have just one implementation because you have so many different usages of it. Some of the implementations can be open source, like the Linux IP stack, but on the other hand, you have other kinds of implementations as well, like, for instance, the Microsoft stack. It might be better, it might be worse, who knows, but the kind of like you have different use cases, so you actually need something else than a common implementation. What you actually need is a standard that onto which you can implement. This means that also that open source and standards are not mutually exclusive. So something that is standardized, you can have an open source implementation of that. And of course, you can later on standardize something that originally had an open source implementation from. When you then coming to more specifically that to some open source projects that we are working on under Linux Foundation. Linux Foundation started in the beginning of a year a new project called Linux Foundation Networking. This is maybe, when we say networking, this is a little bit of an, how I would say, a broad sense of networking. So it's not like routing or anything like that. It's actually a little bit more on top of what happens on a network. But anyways, the thing is that these were existing projects that were already under Linux Foundation, but they were completely separate. What we wanted to do is to put them together and start actually sharing some of the resources. Well, first of all, one of the resources we wanted to share was money, because it becomes quite expensive to have completely separate projects with their own infrastructure and so on. But what was even more important was actually to start sharing something like the CI/CD pipeline and the tools, because actually when you have the third project that starts to build completely similar CI/CD system, completely separate from other projects, it doesn't make a lot of sense, especially if the goals are relatively equal. The Linux Foundation Networking has actually, it has originally, or now from the start, 5 projects underneath it: ONAP, Open Networking Automation Platform; OPNFV, Open Platform for NFV; Open Daylight, which is an SDN, open source SDN controller; Panda, which is a big data framework; and SNAS.io, which is basically networking fault management system in a way. These are the first ones, but we expect other projects to come along as well underneath here. There's actually quite big good support now from the industry, so we have how Linux Foundation likes to count that 65% of the global subscriber base through the operators, but let's just say it, we have the biggest operators there. We have most, or actually all of the significant network vendors. So that relates, what that end results to is basically that we have about 100 members, and 27 of them are in the highest layer of the membership. I think that there are about 94, 95 vendors, members that are basically companies, and then there are some universities that are associate members as well. What I wanted to talk about here is the Open Network Automation Platform, or ONAP. So ONAP is actually a cloud automation platform that was started with when AT&T put their code called eComp together with China Mobile's code called OpenO, and that always, when you take a lot of code and put it together, it's of course great, makes it really great. But anyways, we put that together and harmonized it and tried to make us a first release out of it. The idea here is basically that it's a platform that tries to automate everything that you have in a cloud, including the automation of the infrastructure, but even more importantly, actually automating the things that run on the cloud. So in a networking sense, the virtual network functions, and actually also automate physical network functions as well. And do this also over the different domains of the network. So not just telecom functions, but also routers and switches and so on. When you put two things together in a way like this, you might as well expect that not everybody can agree in the first phase. So this has a little bit, we have a little bit of a challenge going forward, that we have to harmonize this a little bit further, because we have basically two architectures for the price of one. So it's in a kind of like a happy hour of network automation systems. You can still see a little bit the differences between the eComp that AT&T put there and the OpenO that China Mobile put there in some of the functions. But the idea is that that shouldn't be too bad, because what we've been working on quite a bit is to keep it or make it modular. The original code wasn't too modular, but make it more modular and make it in a way that something that a very big operator has deployed in their network doesn't have to be deployed in that huge chunk as one, and that there is a possibility of a little bit of different use cases, and also of different architectures can be supported on it. This is relatively new project. We started it in the beginning of 2017, and we have had now 2 releases out of that software. So the first release was called Amsterdam, came in the end of 2017, and the newest release, which is called Beijing, came actually this week on Tuesday. The idea was basically that the first part of last year was used to do a little bit of harmonization and making sure that things work together. And also, what is a big thing in a big community like this, also to make sure that people learn to work together, try out the CI/CD system, try out the release policy or release process that you have, and that came to the Amsterdam release. In Beijing, we already started to work a little bit more and making the code a little bit better, and also make it a little bit more deployment ready in the way that is actually more robust and would be more usable in a commercial setting. In the next release, which is called Casablanca then, so as you might notice, they go alphabetically and they're all city names. So the next one is Casablanca, and that would come out in October this year. The discussion about what the actual theme is a little bit under discussion, but it's actually deployability is one of the key things there. So actually installing the software more easily is one of the key things that should come out of it. So if you look at the who are the contributors to this, AT&T and Huawei and Amdocs were the ones that were working on the original code. So AT&T and Amdocs were working together on eComp, and Huawei was working with China Mobile a lot on OpenO. We came a little bit later here, but we have started to also actually contribute quite a bit of code there. But the important thing here is that we actually have a fairly good support in the industry of actually people providing code and contributing and making the code base better. In the kind of like looking at open source still a little bit more generally after this is that we see that actually this model of doing open source together in places where it makes sense is something that is going to only increase in the future. It doesn't make a lot of sense, the thing that what we have done before as an industry, which is basically that everybody has implemented something by themselves, and so which means that in the industry something that is not really differentiating to your product, we're implementing 5 times or 3 times throughout the industry. It makes a lot of more sense that we work on that together and we can actually create frameworks that are compatible and can be then more easily deployed. And actually the work that what is done in the industry goes more to the things that actually do differentiating things and also have actually innovation rather than doing the generic things. This is something that is clearly coming part of our company's development, and I think that this is becoming part of the normal R&D process by at least of our biggest competitors, but I think this is coming as a part of normal development for everybody, every vendor in the industry. But this doesn't mean that there wouldn't be any products anymore and everything would be open source. The differentiation will continue and the innovation through the differentiation as well. So that was a quick thing to Linux Foundation networking and ONAP and open source as general. Any questions? I have been able to put everybody to sleep. That's actually pretty good.
Well done.
Even after a coffee break.
So, are you going to be at the sauna for more questions?
Oh, sure, yes.
Yeah. I think that's, after a few beers, the best questions will be generated.
I don't know if the best, but questions at least.
I confirm that there are questions after beers. Thank you so much. Yep. You want to wear the thing? Yes. Here's half of it. Here's the other half of it. Now there was it was Paul's presentation, I think, where there was a discussion about Nat64 and how it must be turned off, or rather DNS64. And now we're going to hear how Nat64 and DNS64 should not be prematurely turned off and how it should be configured, I think. Yep. And also some tools to figure out your Nat64 and DNS64 implementation. So I'm going to hand back over to Jan, who's going to tell us more. Thank you.
Thank you very much. Do you hear me? Does this work? No? Okay. Apparently he needs to put it on. Okay, so it's Jan George again. I submitted 2 presentations. I was once on the agenda, but I submitted 2 because I knew sometimes people don't show up. So what I want to talk to you today is about Nat64, DNS64 real-life experiments, and one useful tool that we built in the past. And at the end, we will we will figure out what is currently happening with the version 2 of the tool. Okay, so does it now work? No, it doesn't work. No. So this is green. Ah, so it's a bad cable, basically. Can you hear me? Okay, excellent. All right. So, what is the problem that was troubling me? Let me walk you through all my 6 degrees of inner turbulence. IPv6 and IPv4 are basically incompatible on the wire, right? They are ships in the night. They don't talk to each other. So at some point in time, we need, if we are on IPv6 only, we need some translation mechanisms to reach IPv4 content. And as it happens that mobile operators, thanks to Google Android that implemented 464 XLET, are more and more using 464 XLET to put Android phones like mine there or everybody else's there to be on IPv6 only network. So if these people want to reach IPv4, then they need to go through Nat64. This is currently the only way of doing it. So there are millions of users. You would be amazed. T-Mobile USA these days have 10 million devices on IPv6 only. And you have 10 million users that potentially cannot reach your website or your services that you are offering on the internet. And not just T-Mobile USA. There is Verizon. There are other people on the planet now enabling millions and millions of devices on IPv6 only. So IPv6 is happening. And lots of questions started coming my way from operators saying, if we implement IPv6 only mobile phones, what will be the user experience? And there is content providers saying, okay, how do we know how our content is seen from different environments that are all of a sudden emerging on the internet? Today, internet does not consist from IPv4 only environments, people sitting at home and just having IPv4. And if you are a developer, if you are a provider of a web service, of a web content, you just go back home, you try from your home link. Does your server work? Yes. Is content visible? Yes. Excellent. Off we go for beer. This doesn't work anymore. There are more environments emerging these days. And also, we figured out that there is some weird stuff that people is adding to their quad A records because they are experimenting and then they put it in production. And this also breaks the user experience on the internet. Perkele. Right? So, okay, let's get this away first. I would like to thank a couple of people and organizations for me to enable this work. Internet Society, they invested lots of my working time into working on this project that was not in the company's the missions and goals, but I did it anyway because it's cool. Then Go6 Institute Slovenia, that I'm still CEO, for hosting the Go6 lab and the equipment there and providing us the place to work. Sander Stefan and Corinne Pritchard. Sander actually coded the tool that I will show you later at the end, completely for free, just because, well, it was a little bit of a challenge. I had this idea how to build the tool, and I built the version 0 of a prototype. I'm not a programmer. I'm not a developer. I'm a network engineer. And I built it in bash scripts, awk, sed, sort, and these things. And when Sander saw it, he said, okay, it works. It shows me what it is supposed to do, but sir, please stand back from the keyboard. Okay, fine. If you can do it better. So he installed the Python environment and Django and everything, and he basically coded the tool. And Corinne Pritchard, Sander's lovely girlfriend. Hi, Corinne, if you're watching, for a lovely design of a tool's front end. You would not like to see what the first version of a tool was. It was like that white blank screen with Times New Roman writing, and you know, the way how we engineers build tools. All right. So, before we started the tool, what happened? Lots of people was asking me, what is this Nat64? How does it work? And I said, well, I have a lab. I have lots of equipment. Why not setting up sort of like the publicly available Nat64 implementations that people can test remotely for free, right? Because I cannot explain to you how Nat64 Check works. I would like, okay, if you have IPv6, disable IPv4, set this DNS as your resolver, and test it yourself. And we have, currently we have 4 different implementations of from 4 different vendors. And actually this is used by software vendors, by hardware vendors to test their devices. It is used by application providers, basically by many people that wants to test their products, how they work in Nat64 environment. I also got an email from guys from Google, from Android. They said, oh, Jan, thank you for running these four different implementations of Nat64 in your lab. We tested our 464 XLAT build in our Android against all 4 of your implementations, and it broke a little bit with one of them, and we figured out we had a bug in our software, so we fixed it. Now it works with all 4 of them. It goes to production. So these things are quite useful. Why we're doing it? Because we can. It's all for the good of the internet, right? Okay, so if we go to go6lab.si and current IPv6 tests and this, here you have the instructions how to use the lab setup remotely. You can do it from here if you want. You have IPv6. You just turn off IPv4. I know it's hard. I know it breaks your heart.
So we have 2 SSIDs here.
Okay.
One is called IPv6 Kohta, which is dual stack, which probably most of the people have been using. And the other one is IPv6 NUT, which means IPv6 noun, which is IPv6 only and sports a Nat64 implementation or DNS64 implementation.
There we go.
So just turn into IPv6 now and away you go.
Yeah, or if you're on IPv6 only, you just change the DNS resolver. I will show it to you. So here you have all the instructions, how this works. As you can see, we have A10 networks implementation. We have Palo Alto networks firewall. We have YOL, that is free open source kernel model for Linux. And we have Cisco ASR 1000 that's sitting in the lab and just doing Nat64. So if you want to use different things, you just insert this IPv6 address as your recursive resolver, and then it will start sending DNS queries to Slovenia, and it will receive back, if there is no IPv6 record, it will receive back the synthesized quad A record, and it will ship packets back to Slovenia over IPv6. Their Nat64 will translate, and then you will reach the IPv4 content. So here, so here is the Palo Alto one. I mostly use this one because this is also my main firewall. If you want to test YOL, this is the DNS. If you want to test Cisco Nat64, this is where you direct your DNS. Sounds easy, right? And it is. It's pretty easy. You, as a user, everything works and everything is fine. I don't believe Skype fixed it yet, but other things should be okay. So this is a real hardware. This is my little lab. This is the hardware. So Sander calls it a systematic chaos, and it is. Okay, let's talk about the enemy inside. Have you ever seen any of these values? Column, column 1. We discussed this before at Paul's presentation. Yes, some people put this stuff into the quad A record, and they actually publish it, not just put in. Column FFF, an IPv4 address. This is not going to work very well. Look at this, FE80 and some value. Wow, just wow. Putting your local, link local IP address into the quad A record and publish it to the world, expecting that people will reach your content on the internet. Well done. This one, 64 FF9B. This is the well-known Nat64 prefix, but if you don't have a Nat64 server that is using this prefix on your network, that's not going to work. And some people claim they don't do copy-paste from documentation and online examples. Right. We have seen the documentation prefix being published as a quad A record. So if you've seen something like this and you know who did it, talk to this guy and buy him a beer or do whatever you want, but make him fix his problem, because clearly he has a problem. There is Dan Wing, an ex-Cisco employee. He is doing the queries. Here is the link where he's publishing the quad A stats. You would not believe what kind of crap, can I say crap? Yes, I can. People put in. All right. So there is, for example, host www.firstinside.com, right? This is some naming and shaming here. Bear with me. Okay, this machine has an IPv4 address of this and of this, but if you ask for host without www, you get has IPv6 address of column. Well done. This is not going anywhere. So who in the room knows what is column? Okay. So column is the same as in IPv4 world, 0.0.0.0/0. You would not put an A record on that, would you? Probably not. Some people does, apparently. Okay. So, again, perkele. What can we do about it? What can we do about it? How can we implement Nat64, DNS64, 464xlat, and not break the user experience? Because when people on IPv6 only devices will encounter a situation like this website will not be reachable, because the DNS64 will not synthesize the proper quad A record that would transfer them through Nat64, but they would also not be able to reach the site over IPv6, because column doesn't lead anywhere, basically, or everywhere. It leads everywhere, basically. So remember, if you're not part of solution, you're part of a problem. That's the basic message here. So I was thinking about how to mitigate this problem. I know that the best solution would be to catch all these weird things that are happening and basically tell people fix it. But if you're a mobile operator, and if you implemented IPv6 only network, I know I've been in operations for many years. If you do something like this, then phone starts ringing and nobody's happy, and your boss is not happy, and basically nobody is happy. So you need to find a solution around, right? So we figured out, okay, IANA allocated 2000:3 as the global unicast address pool. So most probably, whatever is allocated outside this pool is most probably completely wrong and shouldn't be there. And that's just a presumption. Okay, when IANA might allocate another block as a global unicast addresses, this will change. But I surely hope that we will get rid of IPv4 before we allocate another block, right, Paul? Yeah, I hope so. Okay, stream of consciousness. My presentations cannot go without at least one configuration bit, snippet. Bind 9. So I was thinking how to fix this problem. And then I found out that you have exclude statement in bind 9. So I exclude 0:3, that's the lower part, and then 4.0.0.0/2, that's, and 8.0.0/1, and also the documentation prefix, because this is everything else other than 2000:3 that is assigned as a global unicast. So if you do this in your bind 9 in your DNS64 configuration, then your server, if your server receives a quad A record that is inside the exclude boundary, that means bogus, it will just drop it and basically synthesize the quad A record for you, so you would go through Nat64 and actually reach the content on the other side. Yes?
What we do at our DNS64 is we also exclude Teredo and 64 prefixes, because they're basically native IPv4 as well.
But this is inside here.
Yeah, we put them in that list in addition to those.
Additionally?
Yeah.
Okay. All right. Break DNSSEC, yes. I will talk about this in the next slide. Yes, there is a moment of betrayal. We need to put in the break DNSSEC yes, because with DNS64, if the zone is signed and there is a record but not quad A record, we need to synthesize quad A records, but we don't have a key to sign these records, and the rest of the zone is DNSSEC signed. So in this case, we need to break DNSSEC to yes, and otherwise, the DNS64 module does not process queries that that request DNSSEC data. So let's go a little bit into this Enigma machine. This is where I ask dig quad A to 4.go6.si. That's just IPv4 A record to my DNS64 server, and without break DNSSEC yes, there was just no quad A record because the DNS server said off. There is nothing that I can serve to you because there are RRSIGs and things like this. With break DNSSEC yes, you can see that I got back 4.go6.si, and this is basically the synthesized record with my Nat64 prefix, and this is IPv4 address in hex. For the unbound example, so here you see I was experimenting with this stuff, but then I decided just to exclude everything outside 2000:3 and be done with it. Of course, there is a very good document that talks about the DNS extensions for network address translation from IPv6 client to IPv6 servers. It's an RFC. It talks about how DNS64 and DNSSEC work together. If you're interested in this stuff, go inside, and here it's fairly well explained what it is. Okay, let's go to some examples. So, firewalls.com. This is IPv4. This works. Nat64, still waiting for the timeout. Indeed, it's very secure. It's very secure. It's running on colon, FFF, and some IPv4 address. Never showed up. This is from Spain. I've been told it has been fixed. IPv6 and Nat64. This is something completely different than IPv4. So if you are serving content on the internet, you would like the people to actually see what you have to offer, right? Not something like this. This is from Slovenia. I felt it would be fair to put some bad examples from my own country. This is sort of like where you can store files, sort of like online storage. And here it said, you cannot access this service because you are not from Slovenia. Well, I'm sitting inside Slovenia, in the middle, like in the middle of Slovenia. What the hell is your problem? Of course, IPv4 and Nat64. So the geolocation tool didn't work properly. Okay, uc.cn. That's the page, very nice. And this is, I have no idea how they managed to do that. I tried to replicate this, couldn't. Well, it was something. Yeah. Well,
I've been able to replicate that because it seems that Apache 2 changes their configuration language every now and then, where my config used to work the correct way, suddenly I noticed that after some recent upgrade, I get that page on IPv6 or IPv4.
well, I tried for 2 microseconds, and then I said, well,
Yeah.
can't be bothered, really. Okay, these German people, they're trying to sell stuff. But if on IPv6 people get this, people would not buy stuff. People would not just not click, because, you know, why would you click on something that you can't see? So this guy is not getting any sales from IPv6 only people. Then we have good server, bad content, the gateway pundit. You see, if you see on IPv6 page like this, it doesn't help you with selling stuff. Then this is this church people. Okay, they put on a quite valid quad A record that sounds like a stateless auto configuration record, and the server was actually responding. You could ping the server, but the web daemon was not listening on IPv6, so it just doesn't help much with all the thing. Then we have this, what's that? Deko Svet, also from Slovenia. There is a working quad A record, as you see, but then you get a bad gateway and game over for the IPv6 only. You stay at 1%, basically. So I'm already showing you the tool now. So if you will see later the tool, we have this resources match. If you press this triangle, then you go into all the details, what was loaded and what not. So here you get the bad gateway and game over. So how to test these things? We need to build a looking glass, right? We need to test Nat64. We need to test IPv6 only. We need to test did all the resources, images, style sheets, scripts load okay? Does it look good to the user? Are there any path-MTU issues? So we built a tool that is called Nat64 Check. I have 4 minutes. Good luck with that. Okay, this is the tool. It was caught in the web. If you go to https nat64check.go6lab.si, and you can go and use the tool. It's for you. It's open. It's free. Here, what you have to do is just type in the URL. HTTP, HTTPS. If you leave out the HTTP, HTTPS, it will figure it out by itself. You can also put in the longer URL. And then press the button, this green button, and here you have a list of all previous tests. And you can see how crazy things are going sometimes. You have some filtering stuff going on, so you can filter results, things like this. And then you receive the result. If you do the mouse over, see, you will see the difference, because this tool actually compare images that he gets from different environments, right? You see, I will go back and forth. You do the mouse over, and you see what is actually the difference. There are lines in the sand that we don't cross. We don't fix brokenness. With this tool and DNS64 server that this tool is using, we don't fix brokenness. We don't fix the crazy stuff in quad A records. If you have crazy stuff in quad A records, you will see the failure here, right? We have 2 instances right now. One is in Go6 Lab, one is in IPv6lab.net from Sander in Netherlands. There are 2 instances. Use whichever you want, or both, to see how it looks from different vantage points. So a little bit of Illumination Theory. How does this work? There are 4 servers. There is a management server, and 1 server with only IPv4, 1 server with only IPv6, and 1 server with Nat64 environment. And then when you put in the request to the management server that you see through the website, it will communicate with these 3 servers. and say in a command line, please fetch this URL. There is a command line browser. And then this command line browser will fetch the content, fetch the images, generate the image, and send it back together with the list of components that are loaded. And then the master server will just compare things together and decide on how your content is seen from 3 different environments. Images and words. This is master and web interface. This is where you access the tool, and this is the under the bones 3 different servers. This one is DNS64, Nat64, and they connect to the internet. So this is the real thing. When you send the request for your URL, you will be reached from 3 completely separated different environments, and it will be shown as people from these environments will see your content. Run the test and calculate the score. Please take the time. Sometimes there are timeouts to wait for from the client and things like this, so it will show you that the test is running. Don't press the button, don't press reload, don't press these things. It will not help at all. It will just make it longer. Just press the button, test, stand back, relax, have a coffee, have a beer or your favorite drink, and the result will come. Okay? Okay, wash, rinse, and repeat. Test your website. You would be surprised. If you have problems, fix them, and test again. If you have hard-coded any IPv4 addresses, in this case, Nat64 will fail. If things fail, be persistent enough to find the issues. Fix your code, fix your servers. If you are a mobile provider, also test the most used servers that are in the wild, so you will see how your customers will see the internet. And repeat until your website is no longer broken. Remember, if you're fixing your DNS issues, if you have DNS issues, it might take some time before your change propagates through the DNS infrastructure all over the world and to our web servers. Wait for a day and test again. We are in constant motion. So, and also Nat64 Check code is available on GitHub. This is version 1. It's free, it's open, everybody can use it. Nobody knows how to use it, other than Sander, but yeah. It's here, you can have a look. You can download it, you can join the team that is developing this stuff. And I will tell you why nobody understands how it works other than Sander, because this is as it is. And we are trying to fix this. We are now working on version 2 of the tool. It's been kindly sponsored by the Internet Society. They are funding Sander to do the work. We are rewriting the whole thing from the scratch. And actually, if you wanted to implement version 1 on your network, it was a complete hell, because everything was manual and things like this. So now, what is happening? It's 3-tier architecture. We have one instance is called Zaphod. That's one component. This is the master of the universe. This is the server that will sit probably in Sander's lab and replicate it to my lab. This is where you could connect, where you will connect and type in a URL. Then we have Trillian and Marvin. Trillian, she is the master of a local universes, and Marvin is the worker. So Trillian talks to Zaphod and is giving orders to Marvin. This pack will be globally distributed. And we just had a 2 days hackathon in Škofja Loka with Sander. We were sitting under the very old linden tree and hacking for 2 days. We basically created the package that basically, if somebody wants to run the instance everywhere in the world, you just give us the KVM with Ubuntu or whatever you want, one Nat64 Check username with the credential and the sudo, and then we just push the whole thing to your server, install, run the Ansible playlist. It's completely automated, and you have fully running instance of version 2 tool. We expect to go live in early beta preview just after summer, somewhere in September. It's sort of like very simple KVM container on IPv4 and IPv6. Everything is packed into Docker containers, and you have no work with it. You just provide the VM for us, and we would like to have as many VMs around the world. So we would push these tests to as many places around the world possible, and then we could compare not just how your content is visible from one vantage point, but also from around the world. We could create a heat map how your content is visible from around the world. So if you want to run an instance, please talk to me in the hallways or in Sauna. I will put you on the list. There's quite a long list of people that wants to run instances, but we will welcome as many as possible to do that. And I see Andy is nervous because I'm way over time, but that's how it is. Yes, the spirit carries on.
It is how it is.
The spirit carries on. Test these things, you will be surprised. And if you like the tool, talk to me. If you don't like the tool, talk to me also. We welcome any suggestions how to improve the tool. Now it's time because we're building it a new version. Use it. And now I have a question. Yes, I have a question. Did any one of you use this tool now while I was talking about this?
Yeah, I did.
Okay, please tell me, what was the result?
Obviously, it was fine.
Nobody's throwing objects at me. Say again?
We don't have IPv6 working yet. That was
So you have an error condition on your network.
it's on the list of things to fix.
Yeah. Okay. Anyone else? How did it go?
Less ads.
Less ads. Well, there are no ads on this tool.
The page you visit.
Ah, yeah. So I receive this comment quite often. I don't see any way of figuring out if there is an ad or not, because it changes every time. So my idea just a week ago, when we were doing the hackathon, was that we maybe, if we see a difference between 70 and 80%, that we actually do several snapshots on IPv4 and see if there is a difference on IPv4, and then declare, okay, this is banner, it's out of our hands, and you are still probably fine, but please have a look. Okay, are there any questions? Yeah. How was your test? Oh, here.
Congratulations. There is one more question in the room, though.
I had a question about the version 2 of the tool. I was wondering, why did you choose that architecture instead of just distributing the Docker files so that people can autonomously install their own instance?
It is still in the decision process. Currently, in current version, yeah, we wanted to distribute the Docker files, but then you would have to configure lots of other things outside the Docker files to be able to run Docker files. So we just decided the best way to do it is just centrally build the Ansible script that just talks to your KVM and sets everything up for you, because it's technically speaking, it's Sander and me, and we don't have time to talk to 1,000 people around the world how to set up the KVM machine. I would rather leave this to Ansible and just set up the whole thing.
All right, we have 3 lightning talks that we need to try and fit before.
Interesting. We are now building the. This will not go in version 2, but we are now building the wish list for version 3. So this may as well be. But we will probably need, because Sander is he is an independent consultant, and we will try to find some funding again for version 3, and if people is willing to fund the localization, then I think Sander will be more than happy.
Okay.
Now I need to go, right?
Yeah, that's very good.
Okay,
though.
thank you very much.
Natalie. It's a great presentation.
Huh?
That's no, thank you for that presentation. I can see it's already sparked a great deal of interest, and I know it will fuel lots of the conversations tonight in the sauna. And it's worth getting right, because Nat64 is the transition mechanism that can ultimately be turned off. Many of them involve your translation mechanisms getting bigger and bigger and bigger. Nat64, you can turn it off the more people enable native. Yep. So we've got to get it right. Yep. Thank you, Jan. Okay, now we're going, and if you need another incentive to turn on native IPv6, I'm sure you've heard this so many times, but in case you need reminding why there's an important incentive to turn on native v6, we're going to hear the latest news on IPv4 transfers from Natalie. So over to you.
And I'll be really, really quick. Is the mic on? Yeah, you can hear me? Okay, cool. Some myth busting and some do's and don'ts. Very quick. Bear with me. So let's start with the million-dollar question: how much space do you still have at RIPE NCC? And it is, at the moment, it's 1/8. 1/8 is not much. We stopped giving out the last /8 a couple of weeks ago, so now we are in the pool of people that gave us stuff back. People that gave us stuff back could be that it's a little bit polluted space as well. It's not clean space necessarily. So we're in the last 1/8 of not so clean space maybe. Other question that we often get, how long do you forecast that will last that 1/8? At the moment, the going rate, we expect it's about a year and a half, maybe 2 years maximum. But the number of members is increasing rapidly, so that's very hard to tell. So we don't make very sticky projections on that. A year and a half, but it could be gone in a year as well. Yes, and once you get a /22, you cannot transfer it for 2 years. So the people who just got a /22 have to hold on to it for 2 years. That's policy. Then I did some country statistics. Pretty hard to read in the back probably, but I was basically trying to find out, is Finland importing IPv4 addresses? Are they exporting IPv4 addresses, or are they keeping them in the country? And overall, the long story short, the majority of space you keep into the country. So you transfer between LARs, between members. But you also export. So the majority is in the country. Second, you export. You don't import a lot. But if we look at, for example, I think it was Denmark. Denmark is similar, but there was Norway. Norway is importing like crazy IPv4, and they're not that much exporting. It says a bit about the state of, well, basically you guys, how large your pools are, because if we see a lot of IPv4 coming into the country, that means there is a direct scarcity of IPv4, of course. But it's good that you keep it into the country. I've got 2 tips if you're looking at the transfer market at the moment to buy IPv4. Number 1, try to buy locally. Why is it so important to buy locally? Geolocation. Let's say if you buy a block from Romania, it might take months before you can use it, because a lot of local content will not be shown on an IP address that was formerly used in, for example, Romania or the UK, etc. So try to keep it local. Second tip I have for you is try not to lease your IP addresses. I know a lot of people offer you to lease IPv4 addresses. Quite tricky to do that. Try to formally get it through the right process to have them actually on your name. Because especially with legal implications and official holdership and stuff, these IP addresses now represent quite a value, so you want to have them on your balance on your name. So that's just a recommendation. The amount of transfers, they keep us quite busy. We have an average amount of 200 transfers a month, so our hostmasters are quite busy. They ask for a lot of documentation. Skipping through these, we also transfer IPv6, we transfer AS numbers, but not in these high numbers as IPv4, of course. Because that brings me to the last point, and that's Ipv4 hijacks. They happen all the time. And another thing that we see is that brokers don't have much supply anymore, so they're trying to get ways to get more Ipv4 in. Now, the brokers are not stealing or hijacking Ipv4 addresses. Most of them, at least, are not. But other people are doing quite some dodgy stuff to get IP addresses onto their name. One of the things that we see going wrong the most frequently, and that's something I would write down as homework, I strongly recommend that, is in the LAR portal. If you're a member of RIPE-NC, go to the LAR portal, log in, and see the list of users that the LAR portal has. If there are ex-employees there, kick them out ASAP. Because we don't know who legally represents your organization. So if that guy with access to your LAR portal starts offering IP addresses to another guy, and that happens, we have no idea to verify if that guy is authorized to do it. So we have many cases in arbitration, for example, where people, disgruntled, unhappy ex-employees, start selling off the production IP space from their employer. Serious stuff. I'm not joking. This actually happens, and I'm not giving anybody any hints here. So take that as a homework. Check the list of people that have access to your LAR portal. Yeah, because we get fake websites, we get fake identity papers. We've got two lawyers full-time, 5 hostmasters full-time, and a guy checking documentation, so ID papers and stuff. So it's a lucrative business and keeps us busy. Yeah, basically, that was it. So I hope this was some quick tips and tricks and stuff that we see happening, and stay safe.
Thank you. Thank you very much. Okay, thank you so much. You're around this evening as well for further conversations, to come up with more ideas for removing assets from former employers. That's a great topic for 1 or 2 beers in tonight. Okay, now Kauto will give us some thoughts on ISP security.
Yes, yes.
Over to you, thank you.
One, yes, okay. Okay, my name is Kauto Huopio. I'm Chief Specialist at the National Cybersecurity Center under Finnish Communications Regulatory Authority. Been there for some 17 plus years. Before that, I did work for KPN Quest and EUNet, so I have quite a bit of ISP background too. This is just a sort of a wake-up call for you all to think and think twice. We have in our regulation this: management network and management connection traffic. The telecommunications operator must appropriately protect the management traffic of the communication network or service to avoid unauthorized changes to be made to the communication network or service components. This is a regulation. It must be implemented. Why I point this here so much is because there has been, and this change was induced into our regulation by a couple of cases, major cases a couple of years ago, where attackers with significant network resources have been accessed core network infrastructure, including core and edge router configuration, even patching router OS in live without rebooting to gain access to specific customer traffic. And well, this is the first time I've ever posted anything from Snowden files, but this is for you to read and think. There is it seems that this is a spy operation somewhere, saying that we have access to Belgacom core GRX routers from we can undertake middle operations against targets roaming using smartphones. This needs quite deep access into an operator network. And well, it's a kind of funny, because I think it's quite the same organization that was putting this slide is actually warning now that hackers are targeting UK energy grid and also Irish power grid compromised by foreign actor. And the report says the attackers then installed eavesdropping software on the routers used by iGrid and were able to see encrypted communications sent by the company. What is the most dangerous piece of equipment at the telecommunications carrier network? It's the laptop of the network engineer. Because this device is used to surf various websites, maybe in the night shift at the NOG, and access to your core infrastructure. That's why we have put this thing that you should separate things. Okay, here are just a very quick thought. This is a lightning talk, so I've just put here some points that maybe were worth considering. From network engineer workstations, access internet only from terminated connections. You are not surfing on from the engineering workstation itself. You are from a terminated connections or something, virtual machine, whatever. But do not surf on the same browser you are accessing your internal component. Remote access to admin segments only with strong authentication. Logging of all access to admin networks, logging of all access to network elements, logging of all commands sent to network elements, storage of logs in a separate log storage network with no access from regular admin networks, detection of lack of logs arriving from some network elements, and also something that is, I know it's very, very difficult to implement, but also somehow verification methods of actually that you are running the software that you should be actually running. So that you should maybe take a snapshot from your core elements and export the software there and run MD5 sums and everything like that to check that you are actually running the right thing. I'm not saying that there is this is something happening every day, but this is something that keeps me sometimes night up and waking and thinking, what would be a really, really, really nasty thing happening. I would also like to encourage you that if you think that there has been something like this happening in your network, actually you have an obligation in Finland to report, because we don't spank for you to reporting to us. We are providing you assistance, because these cases are really hard when this happens. But okay, this is a very, very, very hard talk at this time of day. Now, unfortunately, I can't reflect you at the Soininen in the evening because I have to drive about 300 kilometers tonight, still more. But I'm just encouraging you to think you are the guardians of privacy of your customers, and you should take that job seriously. And these, as you saw, I mean, this Irish grid alert was just well, less than a year ago, and you know VPN filter case here, which is naturally Soho CPE side of things, but it's about the same thing. It's network element being used to access customer data in monitoring. I'm really interested in any reflections or comments. You know how to reach me. My personal address and PGP key on the Vaikara National Cybersecurity Center website, or just reach our duty officer. But please don't, if you see something like this, take it up to your own corporate security and come to talk to us, because we really want to get these. If there is something like this going on in this country, we would like to get it away. Thank you.
Very good, thank you.
One more slide. Actually, read also this. The telecommunications operator must ensure that no services or protocols that are unnecessary for the provided communication service are enabled in the components of the associated ports of communication networks or services in the operator interconnection or customer interfaces. So make sure that your network footprint, your big fridge routers are not having an SSH port open to the open net, and things like that. And also, when you're providing customer equipment providing CPE equipment to your customers, please try to think of a sensible configuration there. That you are not providing only the necessary access to that device from the net if needed at all. Thank you.
Thank you. Thank you so much. I'm going to hand over to Raymond for the final presentation of the day on some work that the ITU are doing, which we think you should hear about.
All right, I'm the only one keeping you away from your dinner, so I'll try to make it fast. The last presentation, I mean, Axel. All right, you got it on. So I do this as a hobby. It's called being a co-chair of the Ipv4 working group for the RIPE NCC. And this presentation is done as that kind of person. I'm not doing this as an employer of my employee. So, where's my thing here? So, a while ago, the RIPE community was asked to provide some feedback on a proposal made by the ITU, ITUT, what's this group? The Surgery Group 20, on another proposal to make a reference model for the use of IPv6 in the IoT. Well, this was discussed in a meeting in Marseille in France from 14 to 18 May on Thursday afternoon. And the community gave feedback on forehand and behind this meeting based on the document provided by the ITU. Well, the main problems are actually that there is actually no problem. There is an absence of a problem in this document. It just doesn't show out any problems there are at the IoT. And well, usually if you write a technical document, there is a problem you have to be solving. And this was not really stated in this document. And even if there would have been a problem, you usually would have some requirements to solve this problem. That was also lacking from that presentation. Then there is the lack of documented operational experience or group practice. This was just a proposal, a plan, an address plan, which has not been properly implemented, or there was no reference to it that it has been properly tested in a lab or anywhere else. So we actually did not know if it really works in practice. Probably not. There were also some factual errors. There were namings of protocols that were spelled and written completely wrong. There were even mentioned wrong protocols in it. It's not very reliable. There is also a lot of misunderstanding on how IPv6 addressing policy works. I mean, I run a network, you run a network, and they're probably all different. So you'll have a different solution for doing things what you're doing. And you have the right to do so because you need to do it that way, because you need to get your things up and running. And so do I. So normally, if there are certain needs for changes in policies, they become aware between operators, between people who use and practically use these V6 solutions. So by them, we get a sort of bottom-up system where the people who actually are implementing these things make the rules that how it should be done. And this is not what the ITU is doing. It's an institute that just gives us rules that you should actually do it like this, without any practical background. So, what is the ITU's motivation for this? I mean, usually if there is all kind of standardizations and all kind of other technical requirements for certain things to get these working, it's done by the community, and it's done by, for example, IETF or the RIPE community. But in this case, it was just told us that, look, you know, this is how we can do it, or this is how it should be done. It doesn't really work in practice like this. So one other thing is that the IoT is not a different internet. It's the same internet as what we're using right now. So we don't see any reason why there should be a different rule for this.